Hello, hello, hello. Why is the music still playing? It's still going. Okay, cool. So, hello, what, what's going with audio? What? Hello? I think the audio might be a little bit of a problem. Let me see what's going on here. Got the right camera. Oh, I bet I've got. That's why. Okay, so I had the live stream open on YouTube in another window, and that was really messing with me. Anyway, hey everybody, my name is Mark Borstein. I'm the CTO of Tremolo Security. I don't have Scott with me this week. Not sure where he is. Hopefully, he'll be able to join us a couple minutes late. But we're going to go ahead and move forward. So this week we're going to do the second part of Chapter 6, Authentication. So last week we talked a lot about OpenID Connect and why OpenID Connect and authentication are so important for your clusters. This week we are going to move past OpenID Connect and we're going to get into impersonation and how pipelines authenticate and go through the labs in the second part of Chapter 6. So in last week we set up our Kubernetes cluster. We got Open Unison up and running with our testing Active Directory. And then once we had our testing Active Directory deployed and Open Unison set up, we went through the steps of integrating OpenID Connect with our Open Unison. So those steps could be repeated with any identity provider. It didn't have to be with Open Unison. But that said, what if your cluster doesn't work with OpenID Connect? And there are going to be a lot of situations where that happens, especially if you're talking about cloud managed clusters. So you're going with EKS or Google or Azure, really any cloud managed Kubernetes. One of the reasons for that is that clouds, especially hyperscaler clouds, have their own identity and access management system. And so they want you to use that when integrating with your cluster. There are a couple of tricks to that, though. First off, you got to know how their identity management works. Second off, Kubernetes RBAC, which we'll cover in next week's show, or at least the labs for next week, is generally not well aligned with the way Cloud IAM works. And so what often happens is, in order to get the right permissions, you end up over permissioning a lot of times. Another reason that you may not want to use the cloud identity for accessing just Kubernetes is if you don't need access to anything else in the cloud, you're just deploying an app to Kubernetes. Why do you need cloud access, right? So that's another reason. And then finally, when you go ahead and run, or who owns that access, right? Like who's going to be the one that is responsible for setting that access up? And your cloud team's got a lot to do. They've got plenty to do. They don't have time to be messing around with RBAC and authentication. And so that's where impersonation often comes in and making it easier to access hosted Kubernetes clusters. And so in Chapter 6, we've got to, let's see, we did this part. So I'm looking through here. So I am on page 196. And we start talking about impersonation. So what is impersonation? We talk about impersonation. Impersonation is I've taken a reverse proxy. I put in front of the API server. The API server is just a web server. It's hosting an API. And I'm injecting additional headers to say, hey, instead of authenticating as this person in the token or this person in the certificate, authenticate with these headers and say, you know what? I'm not Mark, I'm Jennifer. These are my groups. And so when you set up impersonation, what essentially happens is now your reverse proxy becomes your authentication point, and then your API server is just blindly trusting your reverse proxy. Now that sounds like it could be a little scary, and it could be, which is why it's important to implement some proper security controls, and we'll talk about that as we start rolling it out. One of the nice things about impersonation is you don't need access to the API server's parameters, configuration parameters, which is why when you start talking about cloud hosted stuff, that becomes kind of a big deal. So we have some diagrams here. We talk about security considerations. Mainly being that if your reverse proxy can impersonate anybody, you want to make sure to put some controls on that, right? And there are two controls that I think are really important, and we'll look at that as we roll out the lab. One being you want your tokens that are being hosted on your proxy to be short-lived. And then you want to have network policies set up to make sure that the only way you're getting to that proxy is through your ingress rules. So you don't have somebody coming at sideways and potentially trying to compromise it. So let's go ahead and get started with our lab. So I am on page, what page am I on? I'm on page 199 in the book, if you're following at home. So let's go ahead. I've got that up and running. Great. And if you are watching from home, please feel free to say hello in the comments. I will happily answer any questions that come up. So I'm going to go ahead and start with, we already have a cluster up and running. So kube control, get nodes. This is a clean cluster, right? So not a lot there. So I'm going to go into the book, chapter 6, user auth, and let's go ahead and deploy OpenUnison with impersonation. So that's very similar to the script that we ran last week. The only major difference is going to be that while running this script, instead of assuming that we're going to configure OpenUnison to integrate with Kubernetes using OpenID Connect, we're going to set up a project called kubeOIDC proxy. So this was a project that was originally started by JetStack, those same folks that gave us Cert Manager. And they ended up having to, they built it. And then in 2020, they ended up not giving it the TLC it needed to keep it up and running. And so at Tremolo, we decided to fork it to be able to keep maintaining it. And so we now manage and make sure it gets updated. We also had a bunch of features to make it a little more useful and secure. And so we're going to deploy that with our cluster, and that's actually what we'll end up interacting with as part of our login and authentication process when we're working with Kubernetes. And so what we're doing now is we're rolling out our operator. It's really weird. There we go. So we've got our operator rolled out. Now we're rolling out orchestra. So if you remember from last time, this is the part that takes a hot second. So if you're out there, please feel free, say hello. Don't have Scott today for some witty banter, which is a little unfortunate. But so once this all gets rolled out, or while this is rolling out, why don't we talk a little bit more about what impersonation looks like? Things still going, right? The VM didn't crash. Okay, there we go. little slow, but we eventually get there. All right, so we've got 2 open unisons rolling, so we're waiting for them to get down to 1. So while this is launching, I will tell you, I've gotten to the point where I actually kind of like using impersonation, even if it is not a cloud managed cluster. Reason being that a lot of times when you start dealing with load balancers and, sometimes referred to as hairpin turns, where go out to the load balancer and come right back in, it can get a little weird with networking sometimes. So I actually find that I like impersonation even when I'm not dealing with a cloud managed cluster. So as an example, I've really been using Talos Linux a lot lately for my development for Kubernetes clusters. And you can configure OIDC with Talos, but I just find it easier to use impersonation. Once I've got that ingress set up and that load balancer set up, it just makes it super simple to be able to manage access. The nice thing about impersonation is it also gives you a additional point of trust. So we'll get into this a little bit later in the labs. But you can, as of today, at least GA, Kubernetes does not support multiple authentication points. So let's say you're running a pipeline in GitHub, but you want to trust to be able to make updates to your cluster. One of the things that you can do with impersonation is set up a impersonating proxy that can trust your GitHub repo. We'll look at something like that once we get a little farther along in the chapter. Just about there. And then now I did say for now GA, because structured authentication does in fact allow you to do multiple authenticators. We didn't include it in this chapter because when we first wrote it, it was still in alpha, which meant it was going to go through a lot of change. It's in beta, I think, as of 31, Kubernetes 1.31. But I don't know when it's supposed to go GA. I was just looking it up. It went beta in April of last year. So you can't be in beta for more than 3 releases. So my guess is if it's not going in 33, which is the next one that is coming out, it'll go GA in 34. So it looks like we're done. And I'm just looking at my lab here. So let's go ahead and log in. Let me grab the URL. And okay, so we already created OU bindings or a cluster role binding. So that will all work. So let's come over here and I'm going to log in. And we don't need to worry about certificates, right? So I'm going to log in. I'll make this a little bit bigger. M. Mosley, and the password is start123. No special characters or anything because we don't want to, we want this to work, not cause havoc with passwords. So just as before, we have the dashboard up and running. And one of the things that is important to understand here, and we'll get into this in the dashboard chapters, the dashboard doesn't have much of any permissions on its own. So the reverse proxy, in this case, Open Unison, is actually passing its token plus impersonation headers down to the dashboard. Now, the dashboard used to say who the logged in user was. They took that out, which was unfortunate. But as you can see, everything works with the dashboard the same way it did when we were using OpenID Connect. So that's important. That's important. So let's come back over here. Let's grab our tokens. And this will probably look pretty similar to what we did in last week's, where you've got all of our different tokens and certificates and whatnot. So I'm going to grab a token. Now, what's going to be a little bit different from last week is last week we ran into all kinds of heartburn. Let me make this bigger. All kinds of heartburn because config. I really cannot type today. There we go. Because we tried to run kube control on a different machine, and I had forgotten that the OIDC lab had to be run on the same machine. With impersonation, and when we do the rest of the labs that involve Open Unison, they'll all use impersonation so that you can actually access your development cluster remotely, which is kind of fun. So like right now, I've got no access to anything. Right. So I'm going to go ahead and set my token. And so we can see now that I have access to Kubernetes. And the really nice thing about this approach is that I'm accessing it through my ingress. So there are no changes to the API server. So if you remember from last week, we had to exec into Docker. We had to set up the kube control configuration parameter, or excuse me, the API server configuration parameters. We don't need to do that, right? Like this is all done using Kubernetes native deployments and primitives and whatnot, and RBAC to be able to impersonate it. And some of the things that are kind of important when it comes to the setup. Let's look at some of the security concerns that we have in place. So let's go back to our dashboard, make it a little bit easier. So if we go to the Open Unison namespace, hey, Kafka, I was worried, bonjour, my friend, you weren't going to end up making it today. So if we go over to the Open Unison namespace, and we're going to go into the kube OIDC proxy. Let's go ahead and exec right in. So I'm going to get var run. What's going on here? I don't know what's going on. My network seems to be a little squirrely today because everything is running kind of slow. All right, we're gonna do this way. Get pods and Open Unison. Yeah, my VM seems to be a little squirrely today. Exec TI. So let's go in here. Open Unison. Open Unison. There we go. All right, so let's go ahead. Cannot type. Var run secrets Kubernetes service account token. All right, so here's our token. And let's go over to jwt.io. I think here we go. Let's go over to jwt.io. Now, quick recap, jwt.io is a great site for making it a little bit easier to take a look at tokens. But please, please, please remember, do not paste your tokens into websites unless you know what you're doing. This case is a development environment, so who cares? So what's important here is our initiation was at 12/11/33 and expires at 12/21/33. So that means that token's only good for 10 minutes. That's a little bit different than the default. Most defaults, token's good, I think, in Kubernetes for 24 hours. It's a long time to cause pain. Using a customized token request configuration, which is what Open Unison's doing in this case, you can cut it down to as short as 10 minutes. So this means that if somebody were to get a hold of a token from Kube OIDC proxy, it's only good for 10 minutes. Now, granted, there's a lot of havoc you can do in 10 minutes. But the point is, it's not good for 24 hours. So you're not in a situation where you've got to constantly like restart pods or delete secrets or whatnot. So that's a big part in helping to mitigate the security risks. Another important aspect of securing your setup for impersonation is making sure that you have, I'll make this a little bit bigger, network policies in place, right? Because you want to make sure that nobody's coming in from other namespaces trying to hit your impersonating proxy. So by default, Open Unison sets these up for you. But if you're going to do it with your own system, you're going to want to make sure have these impersonating or have these network policies in place. So that way you are limiting traffic coming in from your ingress. You're not limiting traffic from or allowing traffic from your user namespaces. So we've done that. So let's go ahead. We did kube control get nodes. Let's prove we are who we say we are, because that also is important. Let's exit here. So k get nodes. Cool. So k, who am I? Or k auth, who am I? Excuse me. And so we can see here that, I'll make this a little bit bigger because text is a little hard to read, and make sure everything lines up. So we have our username. This is how the cluster sees us. This is who the cluster thinks we are, is M. Mosley. These are the groups that my user is a member of according to the API server. So I'm in group 2, I'm in a cluster admins group, and I am system authenticate. So this last one's really important. If you're going to implement impersonation on your own, and you're going to do your own impersonating reverse proxy, one, please don't. This is really easy to get wrong, especially for a reason we're going to talk about here in a minute. But also, if you are, impersonation does not add any default groups, and system authenticate is one of those default groups. So if you're using a group that is not privileged, you start getting 403 errors because you're not authenticated. So that's one to make sure that you're adding. And then we've got this extra, which is credential ID. This was added in Kubernetes 32. And so once the kube control client 32 for proxies. So KubeOIDC proxy is now running for 32. So even though this is Kubernetes 30, 1.30, we're on KubeOIDC proxies using the 1.32 client. So that's why that's been checked. Now, here's something kind of interesting. Let's see here. Oh, and just as before, let's go ahead and show the logout process. So I come here and let's close that. So I'm going to go ahead and log out. Beep. So I'm logged out. And now watch kube control get nodes. So in a second, it's already broken. So the logout process cleared that out. So that's something that's important, especially when you're talking about any kind of privilege. So let's talk a little bit about other uses of impersonation besides just authentication. What if you are rolling out RBAC bindings and you need to test them, right? Let's say you are onboarding a new application and you want to say, hey, how can I test this setup? Well, one way you could do it is get a token issued for that account, but that can be a little bit painful. So kube control has this great functionality called the --as and the --as the --as group. So what that lets me do is act as somebody else, assuming I'm allowed to. Now, the interesting thing about that is it's using impersonation. It's using the exact same technology. So let's see what this looks like. So I'm going to go ahead and log in again, right? Because I logged out. So let's log in. And I'm on page 201 for anybody following along with their book. Yeah, my VMs. There we go. All right. So let's grab a token. And let's go ahead, come back here. So I got my context back. Okay, so now I'm able to log in again, and let's do k auth. Who am I? So I'm still Matt Mosley. So I'm going to do a kube control get nodes as some random user. And it failed. And the reason is because Kubernetes was evaluating RBAC as if I was some random user. Now, anybody who's watching at home, and let's show what this actually looks like. So I'm going to do v equals 11 to show all of the gritty details. So if we look at, this is the request, and I'm looking for, no, that's the response headers. I want the request. I want the request. Those are response headers. I don't want response headers. I want request headers. All right, set cookie. I guess they stopped doing, did they stop doing request headers? I guess they did. Well, the point here is that when you go ahead and get the node, when you go ahead and get the nodes, what's happening here is that kube control is adding the impersonation headers, sending it to Kubo IDC proxy. Kubo IDC proxy authenticates the user. Now, this is where things get a little bit dangerous, right? Because I, as a proxy, need to somehow make sure that you, as the user, are allowed to authenticate as some random user, right? Because what you don't want to do is just let anybody impersonate anybody else. So there's RBAC in there, and we've got the RBAC rules in the book. And so one of the things that Kubo IDC proxy does, and this is something that Tremolo added, was we do a service access review and make sure that before we allow the request to go from Kubo IDC proxy down to the API server, that we've made sure not only are you Matt Mosley, but that Matt Mosley is in fact allowed to impersonate some random user. Now, they are allowed to impersonate some random user because they're a member of a cluster admin group. So they're allowed to impersonate anybody that they want. So that becomes really important, that in your proxy, make sure that you're taking a look at that. And you're not allowing users to just impersonate whoever they want. So you can also impersonate groups. So before, we ran nodes, some random user, it didn't work. Now we're going to say that our user is actually group our cluster admin group. So I'm actually going to cheat here. K auth who am I? And then we're going to do as group. And let's grab our Kubernetes group. Now that worked. And that worked because Kubernetes says, even though some random user doesn't have any RBAC bindings to them, some random user is a member of the group CN equals Kate's cluster admins coming out of my LDAP. So Kubernetes says, okay, well, I don't know who some random user is, but I know what that group is, and I'm going to authorize it. Now, this should be a little interesting. So here's the who am I, and you'll notice that the username is some random user, right? Because that's who we're impersonating using kube control. But we have this extra information that says, here we go, extra original user and Mosley. That's because inside of your API server log, if you do something as an impersonated user, it's going to say the user that you did it as is the impersonating proxy. So if you look in the API server log, then we'll see this next week when we get into RBAC, you'll actually see the impersonating proxy, and then it'll say, but it impersonated this account. So some random user. Now we've got a double impersonation going on here though, because I am testing out some random user using kube control. So I want to make sure the API server knows, wait a minute, not only is this an impersonation of some random user, but it's an impersonation of some random user by Matt Mosley. So all the extra information ends up in your API server logs. So that way, when somebody says, well, who did this as an impersonated user, you not only know when you're using kube control as for your testing, you not only know who was impersonated at the kube control level, but also at the proxy level. So you want to have that traceability all the way back. And these are things that are really important to think about when you talk about, especially in the enterprise where compliance is such a big deal. How do you know who did what? This gives you that chain of evidence. All right, so we did that on page 201. So now we're on page 202. We start getting into the RBAC policies. Now we're not going to dive too deep into that because next week is RBAC, and that's everybody's favorite subject. Everyone loves RBAC. So we talk about inbound impersonation. We already talked about the need to do the need to make sure that your impersonating proxy is in fact your impersonating proxy is in fact not only doing the authentication, but also tracking, if you're doing kube control as, being able to track and make sure that the user is authorized to in fact impersonate other people. Then we get into privileged access to clusters. So this one's a really interesting topic. Your compliance folks especially are going to tell you that you need to have some way to differentiate between a regular account and a privileged account. Now, Kubernetes is in itself kind of a privileged system. So I'm kind of the opinion that you should treat it as privileged, and anybody who has access is privileged. But there are people who say, we want to have different ways of accessing it based on based on a privileged account versus a non-privileged account. And there are kind of different mechanisms for doing that. One of the mechanisms is by impersonating a privileged user. So what you could say is, so I am, I'm auth. So I'm Matt Mosley, right? But I could do, as and Mosley privileged, right? And so at that point, my username, my groups would switch over to that. The thought process here is that this is kind of like sudo, where you say, okay, I'm going to sudo as this user. A lot of problems with this approach. I really don't like it. The first is that you now have to have RBAC bindings for not only your user, but also your admin user, right? Your privileged user. And so that becomes an issue. And if your privileged user is different groups, that you have to have RBAC specifically for that user for those groups. You cannot say, users, this specific user, users are only able to impersonate these groups, or like it's just strings that the matching is done on. So that means you have to have an RBAC binding for Matt Mosley to be able to impersonate the user M Mosley with these groups. And you have to specify those groups in your -- as group. So that's painful. I don't think it's a very good use. It doesn't really stop anything because it's not like you're being asked to re-authenticate, which is something that you can do with sudo. Typically with sudo, you want to force the user to re-authenticate, or you want to be able to, or you don't have a password to begin with, right? But in this context, this approach, I've seen it a lot. It's one of those things where, in the fight between compliance and security, compliance always wins. I wouldn't recommend it. It's not something that works well with Kubernetes. One of the things that I like doing, to be honest, is to be able to do temporary authorizations. And so, and keep an eye on this space, because I'm hoping to release something a little later this spring, early summer. That's going to make this a lot easier. But the idea being that I already have an identity provider. That identity provider has all the groups I'm a member in. Instead of having a RBAC binding that changes, have a group binding that changes, right? So I log into my identity provider. I say, please give me privileged access. I'm now a member of that privileged group for a limited amount of time. You want to bind that to some kind of incident or action or something, right? Because we're talking about enterprise here. We're not talking about, just our lab. You usually have to have that tied for compliance reasons to some kind of event, approval, change board, etc. And so add the user to that group temporarily, log it somewhere so that way somebody can track it. I do my work. I have short-lived tokens, right? Once the work is done, delete the session so that way I can't, reuse that token. Token's got to refresh. So I only have this privileged access token for at most a minute after it's expired. And then, deprovision the user from the group. And so now you're using your identity system to manage that privileged access rather than trying to do something funky in RBAC. And, it gives you just a much better user experience. And I'm doing this with customers now. And it's so much easier than having to deal with a tool that's meant for testing to try and use it as a security tool. So we have spent a lot of time on user authentication. Hey, Alan, how you doing? Okay, group bindings. Can you elaborate on group bindings? So I'm not going to dive too deep in that, Alan, because next week we're going to do RBAC, and RBAC is really where the rubber hits the road there. But real quick, let me go ahead and bring this up. So I'm going to go over to dashboard. And so I'm going to go to cluster role bindings. So when we rolled out Open Unison in our setup, and the dynamic access mechanism. Okay, so let me walk through. That's a good point. So I want to stop showing this and show here. So it still works. So I'm going to come here to my cluster admin, and my cluster admin is a member of the group CN equals Kate's cluster admins, right? So let's pretend for a second that my access to that group is not static. Let's see here. Is this something I can do easily? I might do this next week just because it's a little bit easier, but let's see if I can do this easily. So I'm going to go over to Active Directory. I'm going to go to pod. see if I can exec in LDAP modify. Okay. No, I'm not going to spend too much time. Maybe we'll come back at the end. But the point being that I'm going to come here at config map. It'll be a little bit easier. So this is the test Active Directory that launches with the lab, and there's a group in here called cluster admins that I'm a member of, right? So I know what I'll do. I'll do this. It's a little bit backwards, but it'll be the quickest way to do this. So I'm going to remove myself as a member. Update my config map, and then I'm just going to delete the pod, which I know is not the right way to do things, but just work with me for a second here. So I'm restarting Active Directory so that way it loads up where I will no longer be a member of that group. And Kafka, this is this kind of rolls with what you're asking, I think, as well. I'm no longer going to be a member of that group, right? I'm going to be a member of no groups, or this group too. So as a user, I will no longer be authorized to be a cluster admin. Now I actually think I might have just broken something myself. Okay, so I'm going to go ahead and I'm going to log out. I'm going to log back in as M. Mosley. Oops. Hope if I put in the right password. So if I come up here, you'll see I'm only a member of group 2. I am no longer a member of the admins group. However, the RBAC binding is still there, right? Like I'm actually going to come here, and I'm actually not going to be allowed to do anything because, see, I'm not a member of a group that is authorized by the RBAC binding. And the RBAC binding in this case, I got to come back here to come back here. So kube control get cluster role binding OU cluster admins O wide. Right. So this is the cluster role binding that I created when we launched Open Unison. This is the group I need to be a member of. So in my LDAP directory, my Active Directory, I'm no longer a member of that group. So I've made no changes to Kubernetes, but I no longer have admin access. So from an ephemeral access standpoint, or limited access, privileged access, the best way to do this is say, you know what, I'm not going to make changes to my cluster. I'm going to make changes to my identity. And so now I'm going to go back into Active Directory. And of course, I'm local. So kube control get. So kube control edit CM test users and Active Directory. So I'm going to go in and update my user account now. I'm going to add myself back into the cluster admins group. Oops. Right. So now I, as Matt Mosley, so now pretend change board has approved my change, right? Whatever that change is going to be. I've got 2 hours to make the change. So I go into a system that says, hey, I have this change that I'm authorized to be on. Please start it. So what that privileged access system does, all external to Kubernetes, goes to the identity system, in this case, Active Directory, and says, okay, Matt, we're adding you to this group, right? So I've been added to the group. Now, of course, kube control delete pods, all and Active Directory. So now I'm cheating because I don't remember what port it's on, what the creds are. So I'm just restarting the Active Directory pod. But once Active Directory is back up and running and I'm now a member of that group, without any changes to Kubernetes, when I log in, I will now have access as a cluster admin. So the thinking is that I've been dynamically placed into this cluster admin group. Once my job is done, right? Once my job is done, I will then have a token that will, to Alan's point, that'll have a dynamic group, correct? Yes. I will have a token that will include that group. So like if we come here now, I'm going to come back over here and I'm going to go to Kube tokens. Here is my ID token. So let's go over to json.io. So this is, I'm authenticated in my old session. And you can see I'm only a member of this groups too, right? So now follow the bouncing ball. I'm going to go ahead, log out. Let's log back in. And Active Directory should be back up by now. Maybe. There we go. So if I look here, I now have this extra group in my profile, right? If I go over, let's go ahead and pull in a new token. There we go. So I'm going to grab my ID token. I'm going to go ahead and open up a new jwt.io. We can compare and contrast. And now I have a token that has my OU admin group. So now my access isn't static, right? The identity system has moved me in and out of groups in order to provide me dynamic access. I have made no changes to Kubernetes. Now, you might also say, well, wait a second, what happens when your window ends, but you still have this token? This token was initiated at 1247 and, or excuse me, it was, it was initiated at 1247 and it expires at 1248, which means this token's useless by the time anybody's got it, right? So what you need to do is then you need to force them to log out. Something that I'll be releasing hopefully in the spring is a way to do this dynamically using Open Unison, where you can request a ticket, get provisioned into a group like this. And it's also going to go ahead and make sure that the permissions all go with it. So, but this is really important, right? Like, and great questions, both Kafka and Alan. This is a really important aspect of enterprise Kubernetes. I mean, this is something Kubernetes does not do well on its own because Kubernetes has no user store. And so having a identity system that will work with you in this way becomes super important to be able to do both your enterprise compliance and your security in a way that, doesn't drive people up a wall. So we've been focusing primarily on users and how users interact, humans. I like to think I'm human at least, interact with clusters. And what we're going to do now is talk a little bit about pipelines. And Alan, thank you very much. You are very welcome. And thank you for coming and asking great questions. So what happens when you have a system that needs to talk to your cluster? And this is pretty common, right? Like pipeline, what's your typical pipeline? And when I say pipeline, a automated process that rolls out a deployment, right? It goes ahead and it builds something. It generates an artifact. It generates a container. That container usually has a tag. Hopefully you're not using the latest. Has a tag on it that identifies it somehow uniquely. I like to use, like, if you're using GitOps, I like to use the git commit SHA short tag. Timestamps are popular as well, but whatever it is, it's been versioned. And then once it's been pushed, you now have to tell Kubernetes, hey, go ahead and roll it out, right? And so then what typically happens is that you've got a process that is external to your cluster that needs to talk to the cluster in order to, do something, right? Like say patch a deployment to roll out a new version. Now we'll talk about GitOps, and that's a whole other conversation. But the point is that it's really common to need to talk to your API server from a pipeline. And so how do you do that? Last week we talked about anti-patterns, and one of the big ones was using service account tokens. Service accounts are meant to identify workloads inside the cluster. They're not meant to identify external systems. So how do you talk to an API server from your pipeline? So that becomes a big issue. And so the first thing we show off, and I'm on page 208, is we actually include a way to identify pipelines using Active Directory accounts. So I will say this is from a customer that they highly regulated, and they had a problem. They had this problem, right? They had all of these pipelines, and their vendor was like, "Oh, just give them a service account." I'm like, no, we've spent hundreds of thousands, maybe even millions, on a privileged access system built around AD. We're not going to just hand out service accounts. That ruins all of our compliance. And so we applied the exact same logic for getting a user token just with an API. So here where I show off, oops, where's my cursor? Getting, this just calls an API. Right, like this is just an HTML front end for an API. So what if you take that API and make it available to users? So let's go ahead and run that lab. So I'm going to go back here. Nope, wrong one. Yep, there we go. All right. So we are going to go to pipelines. Right. Yep. Okay. And then we are going to go into the token login chapter. Yep. All right. And we're going to do a Helm install orchestra token API token login. Nope. I got to go up one. Helm install orchestra token API token login. So that's going to be the subdirectory that has it in the Open Unison namespace. And we're going to use our values that got generated. So what we just did was we deployed an additional Open Unison application. We don't get into the details of what that means because didn't really want this chapter to be a chapter on how to do Open Unison. We got lots of documentation on that. We wanted to focus on how Kubernetes does authentication, how you're going to interact with Kubernetes. So, but the code's in the book. You can always check it out. And so now we've got this additional application that will actually allow us to authenticate as a user inside of our Active Directory. So copy and paste is a little bad out of the PDF, so I'm going to clean this up a bit before I go ahead and execute. Actually, no, that'll work fine. So I'm going to run. This is, where am I? I'm on page 209, and that didn't work at all. Why didn't that work at all? Oh, that's why, because there's a space. Needs to be a space there. Nope, wrong one. Here we go. Let's try that again. Nope, still does not like it. All right, I'm going to do it this way. So it's all on one line. Okay, should be good now. Bring it back up. Okay, so helps if this is your reminder that when you're doing these labs at home, make sure to use your own IP address. Once more, This time with a little bit of feeling. There we go. All right. So if I do echo kube az, I now have a token for my cluster based off of the pipeline service account, right? And whatever authorization that has. So I don't have to have my pipeline log into the Open Unison web UI, right? Because that would be a little cray-cray. I have my pipeline just authenticate with that account. So I'm going to go ahead and, because that's only good for a minute, we go ahead and run that again. And then I'm going to run our curl command, because our curl command will work with our token. Just going to clean this up a little. We are on 53, right? Yeah. So I'm just going to use the environment variable that's our token. And then that is my, that's actually my Kubernetes proxy, but in this case, my API server. And so you can see that worked, right? Now, because these are short-lived, oops, why can't I, that still works. So watch, interesting. So we're going to let this go. And actually, we can already see it's unauthorized. Why? Because that token was only good for 1 minute. Now, that's if we grab the token itself. If we wanted to, we could actually grab, because this is actually pulling in all the same stuff that the web UI is pulling in. So if we've got a pipeline that is using one of the many Kubernetes client SDKs, we can actually just pull in our kube control command the same way that we did before, and the same way that we did as a user, but as a pipeline, and let kube control constantly update the token. So you don't have to grab just the individual token, because that could end up being annoying, because then you get people like, well, my pipeline might run for 10 minutes. What happens then? This gives you that same level of flexibility with the token or with your pipelines as you do with your users. Where are we? So we're over here. How am I doing time check? So we're going to run a little bit late today, but I want to wrap this chapter up. So we already showed off what happens when the token expires. So that's a great way to do it. I think it's the best way to do it. It gives you your compliance. You've got short-lived tokens. It lets you integrate with whatever your existing identity system is. And we're going to get into using tokens at the end of the chapter. That's going to be the last lab. So we'll talk a little bit about that. Last week, I talked about how certificates are a terrible anti-pattern in Kubernetes and should never, ever, ever, ever use them except for break glass. Well, that is a hard rule for me, and I don't think it's a good way to go. I would hear the argument for using it for pipelines. And the reason why I say that is it's a lot easier to do correctly for a pipeline than it is to do for a human. I would still call it an anti-pattern, but it's not nearly as offensive to me as doing it for humans. You still have the problem whether you're doing it as a pipeline or you're doing it for humans, of the fact that Kubernetes doesn't have any kind of CRL support, so revocation support. So once a certificate gets minted, it's good for as long as it's been issued for. So if you only have a choice between certificates and service accounts, I'd probably go with certificates. But I would do it crying and under protest. So I'm on page 210, and let's go ahead and show what it looks like to actually do this with certificates. So I'm going to go ahead, and first thing you gotta do is request a certificate. I'm gonna paste that. And nope, wrong window. I'm going to clear here. So I'm using the OpenSSL command to go ahead and generate a new certificate to line up with the service account. And so really not a lot going on here. We just generate a cert, right? So these are new files. We've got a CSR and we've got a key. So the next thing I need to do is I need to go ahead and create a certificate signing request. Now, one thing that's really important when we start talking about this, let me clean this up over here, is that you cannot use, I thought that was going to happen. You cannot use this approach with most cloud managed clusters. Okay. And the reason is that the clusters do not have access to their signing key. So like if we were doing this on EKS and I tried to run this, it would fail because EKS clusters don't have access to their own signing keys, which makes a lot of sense, right? If you're a cloud provider, you want to make sure that your customers aren't out there, minting certificates that can run as nodes, right? You're managing it. So this wouldn't work with I think most cloud managed instances. So I'm going to go ahead and create my certificate signing request. And so what the certificate signing request did was it pulled up our CSR. CSR stands for certificate signing request, because the correct way to actually do any kind of certificate authentication is you generate a key, you generate this request. The request goes to the CA, in this case, our Kubernetes cluster, to get signed. It comes back, that's your certificate. Okay. The problem is often that this process is a pain in the butt and requires some knowledge and is difficult to automate. So what people will often do is they'll say, okay, here's a script that I ran that generated your key pair for you. Here, go use that. And now you've eliminated 90% of your security for certificates, because one of the key aspects of certificate authentication security is that key that we generated, right here. This key never leaves the device that it was put on. And like ideally, it goes into some kind of hardware-based system. So we've got our certificate signing request. It's been created. And then the next thing we need to do is we need to approve it, right? So this is where things get kind of like, well, who's approving it? Well, you have to have RBAC access. So I approve the request, right? So now we're going to go ahead and grab our certificate. So we got to pull this out of the API server. Now, you need to have access to be able to do this, right? Like this isn't just, this isn't something that just anybody can do. So this is step 4 on page 211. So I've gotten the CSR, and let's look at the CSR, right? Cat, SA, cert, CRT, excuse me. So that's our certificate, and let's drop it into OpenSSL X509 inform PEM no out text. So this is going to tell us what's in there. So it's not a CA certificate. It was signed by our Kubernetes API server. And this is the important part. The organization is Kate's. The organization is SA cluster admins. So this means that any group binding to the SA cluster admins group will be whatchamacallit. Sorry, I just lost my train of thought. So in a certificate, you can set what groups you're a member of using the O subject. So here we're saying this certificate is a member of the SA cluster admins group. which means any RBAC binding to the SA cluster admins group will apply to the cert. So this kind of gives us some of the benefits of group-based RBAC. The downside is, though, is look at this not before and not after, right? It's good until 2026. So now think about this. You decommission that pipeline for whatever reason, like you just don't need it anymore. Well, the certificate's going to be good until 2026. And there's nothing you can do about it. So let's go ahead and use our new certificate. So let's assume that we are in our pipeline. So first thing I'm going to do is I'm going to go ahead and make a backup of my kubeconfig. And then I'm going to set my kubeconfig to said backup. And now I'm going to set my credentials. And I'm going to do that based on my certificate. So that's going to change what key I'm using. Because right now I'm using the master key, right? So if I do kauth or kubecontrol auth, who am I? Right, I'm logged in as Kubernetes admin. This is what was created with the when the cluster was created by Kind. So now what I'm going to do is I'm going to change the credential to my key and my cert. So now if I do that same who am I, I'm logged in as SA cert. I'm a member of SA cluster admins using TLS authentication. Now, if I try to do kubecontrol get nodes, it's going to fail because I'm not a member of any group that allows that. So we're going to go ahead and unset kubeconfig. Right? So now I'm back to being me, right? I am who I am, Kubernetes admin. So let's go ahead and create our, I think I'm in the pipeline. Am I still in pipelines? LS, PWD. Yes, I am. So kubecontrol create F, SA cluster admins. So I just created a cluster admins binding for that group. Config gets. Yep, what's going on here? My VM just froze up. What am I feeling? There we go. Kubeconfig gets. Now we're going to do SA config. Right. So kubecontrol auth. Who am I? Yep. So now if I do kubecontrol get nodes, because I created a binding, now I have admin access. So double-edged sword, right? It works really well, but now I have no way of turning it off. If you have no other choice, it's better than a service account, but not by a whole much, right? All right, so we've got one more example is using the pipelines identity. And I do apologize for going late, but this one's really important. I am a big fan of this approach. This is the best way to do it. In fact, I'll add it as a comment on the stream. I've written several blog posts of how to do this with like GitLab, GitHub. I've got one in the works for like Argo workflows to use a clusters identity. Spiffy and Spire are great ways to do it. We didn't have time, unfortunately, to integrate that into the book, but I do plan on doing a blog post on how to do that as well. And so this is really important because ideally what you want to do, and what I'm actually going to do here is while I'm talking, we're going to go ahead and start over. Chapter 2. All right, so I'm going to do kind delete cluster and cluster 1. So I'm going to delete the cluster. I'm going to restart because we're going to redeploy everything. And I'm going to create cluster. So let's go ahead and create a new cluster, give that a minute. So what we actually want to do is we've talked about how service accounts are identities for pods, right? Well, you can use that identity to talk to more than just an API server, or you can use it to talk to even remote API servers. And so that becomes really important for being able to securely access things, because now you don't have to generate an identity, right? Your API server has done that for you. We've already shown how the impersonating proxy, talks to the API server using a token request or a token projection, and so you can do that with your workloads. So let's say, for the sake of argument, you're running Jenkins or GitLab inside of your cluster, right? Your pods or Argo workflows, which is the blog I'm working on now, your pod identity is the best thing to use, because now you don't have to worry about generating and trusting something, right? You just need to get something that will trust it. Now, prior to, I'm just going to do a watch on kube control get pods all. So we're going to wait for the cluster to come up. So prior to Kubernetes 1.30, I think it actually might be 31. You could only have one OIDC provider for a cluster. And so it actually made it kind of difficult to have multiple sources of identity. And so you could do it with your identity provider, right? Like most identity proxies, whether you're talking about OpenUnison, Dex, Keycloak, there are a bunch of others out there, will let you integrate with multiple identity providers. So you could do it that way, right? That's kind of what we showed with, that's similar to what we showed at the beginning of the chapter, where we said, hey, we're going to get an identity. We're going to get an identity from our OpenUnison and use that to interact with our API server. So you could do that. The other route is to try and get Kubernetes to trust directly your, what your pipeline is running on. Now, this should not be that big of a deal, because if you remember to last week when we set up authentication, all we did was tell Kubernetes, hey, just go to this issuer, right? That issuer has everything you need to validate these tokens. Problem is that your pipeline, if your pipeline, let's say, runs on GitHub, but you're authenticating users to Active Directory, Kubernetes can only talk to one issuer. So that was prior to 1.30. When 1.30 came out, they added in beta, or no, alpha, beta, I think it's in beta now, structured authentication, which allowed you to set up multiple authentication issuers for tokens. Plus, it has lots of other nice features in there, like you can use CEL, which is this non-Turing complete scripting language that Kubernetes has been adopting everywhere to make life a little bit easier. To be able to say, hey, we're gonna, we'll go ahead and let you add a little bit of logic in here in a non-Turing complete way. And so now you can trust multiple issuers, which is great. The question is then going to become the same question that you have with existing cloud hosts is, are they going to support it? Now, most of them have said yes. They don't really know how yet, because it's the same problem. Like, how do you trust something? How do you integrate certificates, all that good stuff. So the other option, and that's what we're going to do here, is we're going to use KubeOIDC proxy, except we're going to use it as a CI/CD proxy instead of a user authentication proxy. So instead of authenticating pipeline, or instead of authenticating users, we're going to use it to authenticate and impersonate pipelines. So I'm on page 215. I just created a new cluster. It's up and running. and I'm going to go to CI/CD proxy. So if you're asking what the CI/CD proxy thing is, it is Kubernetes proxy with a Helm chart specifically for this use case. And I'm going to go pipelines, right? And then CI/CD proxy. And I'm going to do deploy proxy. So what this is doing is something very similar to what we saw with OpenUnix, except we're just deploying CI/CD proxy or Kubernetes proxy. So we're not deploying Orchestra, OpenUnix, any of that other stuff. We're starting off with Cert Manager because we need a certificate that gets trusted. And so this will make it just a little bit easier. And this can take a hot second, unfortunately. But once this is run, then what we're going to do is we're going to run a job that is actually going to connect to our API server as a user through our proxy. So like if I do kube control get namespace here, there we go. So we've got this CI/CD proxy that's running, right? And there's our Kubernetes proxy, and we're waiting for it to come up here. Wonder if it broke. Okay, get events. Trusted issuing. Okay, so we're waiting for certificates, it looks like. There we go. So the proxy is running. Okay, control logs F. So our proxy is configured to trust tokens generated by our API server. That means any pod that launches can hit this proxy. Now, if you think about that for a second, you want to be careful because you want to make sure that this is kind of circular logic here because I didn't want you to have to set up multiple clusters to make this work. We show this off in the blog posts as well. But we're trusting the API server's own issuer. So that means any pod in the cluster can hit this API proxy and authenticate to the API server. Now, that seems a little silly. Why would you do that inside the cluster? That, again, we wanted to make this a little easy to test out in the lab. So I'm going to go ahead and run workflow. And then let's go ahead and check out the job. And it's waiting to start. Come on. There we go. All right. So what happened here? We got so this is our token, right? This is our token from the API server. We set a remote cluster. We did something. Unknown. Let's see. What didn't work? So let's take a look at our. So we had authentication success, right? So it authenticated the service account from the CI/CD namespace. So that was okay. Was there an RBAC rule we had to do? Let's see here. So it did not like that. Kube control, get pods, and CI/CD namespace. Yeah, it does not like that. Kube control, get jobs, and oh, I bet I know why. I need to update the CI/CD proxy RBAC to allow the additional. All right, so we're going to cheat here. Kube control edit, kube control get deployments, and CI/CD proxy kube control edit kube OIDC proxy CIC. Can't type to save my life. It's only like I do this professionally, right? All right, nope. Edit deployment. All right. So I'm going to cheat here a little. We're going to downgrade this. And we're going to drop this down to, I think, 6. So watch kube control get pods and CI/CD proxy. All right, so it's coming up and running. So what I had to do is I had to downgrade it because I needed it to an older version to make sure that it wasn't injecting an additional impersonation header. So again, RBAC to the rescue. So this will be up and running here momentarily. And then I'm going to go ahead and kube control, delete jobs, all, and CI/CD/NS. And let's try this again. Run workflow. Really? Kube control, delete CM, workflow data, and CI/CD namespace. Control, delete, namespace, CI/CD/NS. We're just going to start over. So we're going to let that delete out. Any more questions? No, but we're almost an hour and a half in, and I got a lot of you were hanging on. So thank you very much. All right, let's try this again. And okay, create namespace CI/CD/NS. We're almost there. There we go. All right, let's try seeing. Did it work? Did it work? Here we go. Yep. So, okay. So here we pulled in the token. We set a cluster for remote. We deleted a pod, right? Nothing super special. So our workflow was actually going ahead and talking to the API server, but doing it through the impersonating proxy. And so that way our workflow is using its own built-in identity. And Spire and Spiffy are a great way to do this. At some point, we're going to do a show just on Spire and Spiffy because it's great tech and I want an excuse to play with it. Yeah, that's the best way to do your pipelines is using that. And like I said, I'm going to update the show I'll put in a comment the links to the blog posts about how you can use Open Unison to do that with like GitHub and GitLab. So that way you can exchange your token securely for a Kubernetes token. And it's got the same anti-patterns for pipelines as for user auth, right? Like, don't use something long-lived. I mean, I know we used Active Directory before. Hopefully you have a system in place that kind of rotates those passwords early and often. But, you know, it's all the same anti-patterns for pipelines as for humans. Don't use service accounts, unless you're in fact running in a pod. Then you can use service accounts. But otherwise, do not use service accounts. Service accounts are not for use outside the cluster. Don't use certificates unless you absolutely have to. Now, if you're running in the cloud and your workload has a cloud IAM policy, that would probably be okay. Like 9 times out of 10, that'll probably be okay. It'll probably be over permission. So if you really want to lock it down, don't. But it's a lot easier to do it that way, and you're not going to run into quite as many of the same anti-patterns as you will with certificates and service accounts. So that wraps up chapter 6. Both were long streams. Sorry for going a little long, but I wanted to make sure to cover everything. And of course, Kafka and Alan asked great questions. I wanted to make sure we spent a couple of minutes on. Next week, RBAC. So we know who you are. Now we have to figure out what you're able to do. So we will have some more fun labs. We'll get into auditing. So same bat time, same bat channel. Hopefully we'll see you next week. And thanks for joining. And of course, if you purchase the book, especially on Amazon, please, pretty please, with cherries on top, go leave us a rating and a review. You can do so anonymously, but it really does make a big difference. Also, they keep discounting the book, and I don't know why, but it's like $45 right now. Today is Wednesday, March 19th. I have no idea how long this will be true for, but it's only like $45 right now. So that's I think $20 off, $20 off on Amazon. So go, if you haven't bought it yet, go. Shoot, stop listening to me. Anyway, thank you so much, everybody, and we'll see you next week.